Hello? Okay, so for you people, we kind of extended yesterday's where I was supposed to finish it, but I don't know, everyone seemed like they stayed up way too late doing homework to even pay attention. So I want to make sure that you guys are on top of these things. Now, P series are really important. Okay, it's really important. These are stuff that you're going to see on the AP exam, definitely. I've always seen one or two questions specifically over this. So we're going to go over and make sure you guys actually have it. So if you don't, please speak up. If you know, questions, please speak. All right, so P series is an infinite series in the form of 1 over k to the p, where k is my integer going in, right? My number going in, starting k equals 1, and p is the exponent on that. So for this one right here, if it's just 1 over k, that's my harmonic, right? We talked about that yesterday. The harmonic series. So we know it's going to be the harmonic series because that's never really going to be convergent. That's going to diverge. So that one's going to diverge. So the harmonic series, okay, so where p is a positive real number, a p series sometimes refers to a hyperharmonic series. Since the harmonic series is a special case of p series when p equals 1, some examples of p series are right here. So now to the exponents here, okay? Exponents, and we'll figure out what they mean here in a moment, okay? Yay, all right. So, theorem for this one. The P series converges if P is greater than 1, diverges if it's going to be between 0 and 1. Okay? Good. All right. See if you can figure that one out. All right, the series. Bam. Analyzing it. So, what am I going to tell about this first one? What's my P? 3. What rule does that follow? Greater than 1, so this is going to? Letter B. What is my P? 1/2. So that's going to? Because it is less than 1 but greater than 0. Super easy now, right? Good. All right, theorem. Bounds with the sum of convergent P series. If P is greater than 1, then it should fit this rules right here, where I'm going to have 1 over P minus 1, okay, is going to be less than the sum of, from k to 1, of my P series is going to be less than my upper bound, which is 1 plus 1 over P minus 1. So 1 would actually just be basically like whatever my, you know what, let's, here, I'll show you. Okay, so yeah, all right. Try this one. A, finding the bounds. What is my P? 3. So it's going to look like this. 1 over. What's it say? P minus 1, right? So it's going to be, which is going to be less than the sum of from k to equals 1 of 1 over k to the third, and that's going to be
1 plus 1 over 1 over.
What plus what?
1 over 3 minus 1.
Okay. So my bounds. Lower bound's going to be what?
1/2.
1/2. 1/2, and I'm just going to write out my sum here. Ah. So the sum is going to be less than what? So 1/2, right, plus 1 is 3/2. That's all it's asking for right here. Find the bounds of these.
So when we write the answer, we gotta write it like that?
Yep. But you're going to put the whole information like all this. I'm just abbreviating. Right. Here, if you want to write it out, equals 1 infinity 1 over k to the 3. All right. All right, we good? Say yes. Okay, so now this next one, you're gonna have to do a little math yourself here. So what is my sum? K to the pi?
Yeah.
Okay. What am I including here?
One. Infinity.
There we go. It's not bad, right? So how am I gonna write this out now?
1 over pi minus 1.
Okay, so does it first satisfy my convergent? Is p greater than 1?
Yes.
Okay, good. So this is gonna turn into 1 over all right, so 1 over pi minus 1. Some weird decimal. I know, 2.14, right? 2.14.
Isn't there a song for it?
Yeah. Just doing the math in my head, so.
What?
No, because it's you're just subtracting a factor of 1, right?
Yeah.
So not a factor of 1, but a quantity of 1. So instead of 3.14, it's 2.14, blah blah blah, right?
I thought you meant you derived decimals for pi.
Yeah, not in my head. Come on, I.
Doing a little bit of
If
math.
I was seriously, I would be better at gambling. Seriously, I would go to Vegas right now and I would straight up win. Okay, I am not that good at math.
Wait, because can't you like count cards? And
Yes, yeah, counting cards it's easy, but
But it's
I
like-
have
it's
you
kinda
recorded
illegal.
here saying counting cards.
no, it's not illegal.
Can they kick you off to catch you? Count
Yes,
cards?
if
But
they
they
catch
can't-
you.
They can't find you.
I know, but am I? Do I have like paper in my hand? Am I doing the math? Am I looking and doing like +1 carry the 2?
That's true.
So yeah. Anyway,
But
but
then salty people are gonna start accusing you. Like, oh yeah, he's counting cards by the way.
and all it does is it increases your chance of winning. So instead of being 50-50, you're now like
75.
75-25 or something like that. Anyway.
That's all you need.
But, and you can still lose if you're doing that too. So don't worry about it. All right. Okay. Is that good? Yeah, you get some decimals on those. Okay, good. All right. All right. So consider bounds to the sum of convergent series. Consider the series where k equals 1 to infinity of a of k, where a of k is greater than 0 for all positive integers of k. Suppose if continuous positive decreasing function over the integral from 1 to infinity, a of k is equal to f of k for all positive integers. If the improper integral 1 from infinity of f of x dx converges, then the sum of the series is bounded by the rules of this and then this. So it's basically, I am taking the integral. Remember how we kind of do the lower? The 1 over p minus 1, right? And the upper, it's 1 plus 1 over p minus 1, right? Yeah?
Yeah.
So I'm doing the exact same thing, but now we're finding the sum of it here. The sum of the integral for this, right?
Yeah.
We're finding the sum of the integral, and the next one's going to be 1 plus the sum of the integral. So it's basically what we just did with the P series a minute ago, right? But now we're having to find the sum first, because it's not going to be in the regular format as a P series. Okay. So, is it in the format of the P series? Say no.
No.
No. So, what am I going to do instead?
We're taking it off.
Integral, right?
Yeah.
Okay. Alright, so I'm going to rewrite that as what? Didn't we already do this? There we go. We already did this one earlier. That's why just for the sake of time, I'm just going back and showing this one right here again. Because we knew it's an arctan, right? It's 4 times the arctan.
Yep.
Okay, good. So it's 4 times the arctan. I know that my sum comes out to be what? Pi. Okay. Because this one right here, as I do this goes to 2 pi. No, it goes to pi over 2. This goes to pi over 2, and this is just pi. So we come up with just pi on this. So if you got questions on how to do this, go back to the video for this one right here. Okay, so now we know I'm going to be at pi here. Okay. So the sum is pi, right?
Yep.
Okay, so now I'm going to start with the lower bound. So it's going to be this. So I'm going to write it as what?
Pi less than.
Pi, right?
Yep.
So it's going to be pi
Less than.
less than what?
Sum.
Sum.
Equals 1 infinity and 4 over x squared plus 1.
Now, this next piece is going to be s of 1.
Yeah. Which is 2.
So what does that mean?
Plug 1 into the our sum.
Yeah, plug in 1.
Right,
Let's do. My first term is going to be my s of 1. So I'm going to take my 1, plug it in there, so it's going to be 4 over 2, which is
yeah.
2. So my s of 1, it should be 2 plus pi. Why do we have to what? Oh, okay, so now, right here, didn't this say a of 1? That's a of 1. That means my first term. Yeah, my first term, I'm plugging in my first term for whatever I have there. So my first is going to be 1. That's why that one came out to be a 2. Does that make sense? Yeah? Okay, good. All right. Oh, that was the last one. Okay, there. Like, share, and subscribe.